Let's talk about how to calculate the lengths of diameters, chords, and tangents. But first, let's review what those things are. A radius is the distance between a point on the circle and the center of the circle. Whereas a diameter is the distance across a circle, so it's a segment that connects 2 points on the circle and it has to pass through the center of the circle. As opposed to a chord, which is a segment that just connects any 2 points on a circle but doesn't have to pass through the center. A secant is just like a chord, except it's a line instead of just a segment. So it connects 2 points on the circle and extends infinitely outside of the circle. And a tangent is a line that passes through exactly 1 point on the circle. In doing so, it ends up being perpendicular to the radius with the same endpoint. The first unique property of segments in circles that we're going to talk about today is that if two chords in a circle are congruent to each other, then their intercepted arcs are also congruent to each other. So for example, if I knew that this arc was congruent to this arc, you label arcs as being congruent the same way that you label segments as being congruent. If these two arcs are congruent to each other, then these two chords must be congruent to each other. So RS would have to be 17 centimeters because QT was 17 centimeters. And the measure of arc RS would have to be 109 degrees because the measure of arc QT was 109 degrees. Pretty easy. We can also apply this idea to algebraic problems like this one. Since these two chords are marked as congruent, I know that these two arcs are congruent as well. So I can set up this equation, 17x minus 4 equals 14x plus 20, and solve. So I get an answer of x equals 8, and I can use that information to figure out the measure of arc RT by plugging 8 in for x. So 14 times 8 plus 20 tells me that the measure of that arc is 132 degrees. The next unique property of chords and diameters in a circle that we'll discuss today is the fact that if a chord and a diameter are perpendicular to each other, then the diameter bisected the chord, and it also bisected the intercepted arc. So here in this diagram we see diameter AE is perpendicular to chord BD. And if that's true, then BD was bisected, meaning that BF and DF are congruent to each other. And that would also tell us that arc BA and arc DA are congruent to each other as well. So let's try an example. Here I have a diameter, QT, and I have a chord, RS, and they're marked as perpendicular. So since those two segments are perpendicular, I know that the diameter cut the chord in half. So since RU is 5 feet, US must be 5 feet as well. And since arc RQ is 78 degrees, arc QS must be 78 degrees as well. So let's throw some algebra in there. Again, we have a diameter and a chord, and they're perpendicular. So I know that the chord was cut in half and the arc was cut in half, which means 4x plus 3 must be equal to 5x minus 9. So when I solve that out, I get an answer of x equals 12. So I can plug 12 in to figure out the measure of arc QS. It must be 51 degrees. And finally, let's talk about tangents. Since a tangent is always perpendicular to the radius whose endpoint is the point of tangency, we know that we actually have a right triangle if you connect a point on that tangent back to the center. Which means we can use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, to solve for some of these lengths. We can also use the Pythagorean theorem to determine whether or not this is a right triangle. Because if it's a right triangle, then AD must have been tangent. If it's not a right triangle, then AD was not a tangent. Let's give it a try. Our goal here is to figure out whether or not line AB is tangent to circle C. If it is a tangent, then CA and AB would be perpendicular to each other. That would mean that segment AC and segment AB are the legs of this right triangle, and segment CB is the hypotenuse. But we only know segment DB's length. It's 9. I need the entire hypotenuse in order for this to work. What's the length of CD? Even though it wasn't given to us, we can figure it out pretty easily because CD is a radius of this circle, and CA is another radius of this circle. And all of the radii in a circle are equal to each other. So since this radius is 8 inches, this radius must be 8 inches as well, which means the hypotenuse is 17 inches. So let's use the Pythagorean theorem to verify whether or not AB is tangent. So I'll say leg squared plus leg squared, 8 squared plus 15 squared, is equal to hypotenuse squared, 17 squared. Remember, the largest number should always be C, and the two smaller numbers are A and B. So simplifying, I get 64 plus 225 equals 289, and that means 289 equals 289. So yes, indeed, line AB is a tangent of circle C because it's perpendicular to radius CA. Let's try another one like that, make sure we understand what we're doing. Our goal is to prove that YZ is tangent. In order for that to be true, it must be perpendicular to radius XY. So we can prove that these two lines are perpendicular by showing that this is a right triangle. 21 is a leg, 28 is a leg, and then XZ is the hypotenuse. Now we only know part of XZ, we know that WZ is 15. But since XW and XY are both radii of this circle, we can assume that XW is also 21 centimeters, which means the entire hypotenuse is 35 centimeters. So let's prove that 21 squared plus 28 squared is equal to 35 squared. So I get 441 plus 784 equals 1225. And when you simplify the rest of the way, you end up proving that yes, indeed, line YZ is a tangent of circle X because it's perpendicular to radius XY. So let's put together everything we've learned so far today to solve some problems. We need to calculate the value of X. And we're told that this little chord segment is 12 meters long, and this radius is 13 meters long. I notice that X is one of the legs of this right triangle. So if we could get the other information about this right triangle, we could solve for X. The hypotenuse of this right triangle is a radius of the circle, and all radii are equal, so I can assume that EC is 13 meters long. I also see that diameter BD is perpendicular to chord AC, and we learned that if a diameter is perpendicular to a chord, then the diameter bisected the chord. In other words, FC must be 12 meters because AF was 12 meters. So now I can use the Pythagorean theorem to calculate X. 12 squared plus X squared is equal to 13 squared, which means X must be 5 meters. Let's try another one. Again, I see that X is one of the legs of a right triangle. So if I could figure out the other two measurements on that right triangle, I would be able to use the Pythagorean theorem to solve for X. Well, I see that KM is a radius, and MI is also a radius. So MI must be 65 feet because KM was 65 feet. I also see that these two arcs are labeled as congruent. If you have congruent arcs, then their chords are also congruent. So that means that chord JI must be 112 feet because chord GH was also 112 feet. But I also see that this chord has a segment that it is perpendicular to, and that segment connects to the center, which basically means it's a diameter segment. It's part of the diameter. So since we have a diameter that is perpendicular to a chord, that chord must have been bisected. So since the entire length of JI is 112, we can take half of that to figure out the length of LI, which would have to be 56. So now looking at just this little right triangle, I can say that X squared plus 56 squared is equal to 65 squared. So X must be 33 feet. For our next problem, we're told a bunch of information and are given. We're told that NQ, which is the length of a diameter, is 60 inches. We're also told that NU and VT are both 48 inches. Those are two different chords, which means they're congruent to each other because they have the same length. Well, if the diameter is 60, then each of the radii that I see in this diagram would have to be 30, because a radius is always equal to half of a diameter. So I could say that NO and RO and TO and QO are all 30 inches. I don't know which ones I'm really going to need at this point, so I just listed all of them. I also noticed that the two chords that we were given the length of are bisected by the diameters. Since each diameter is perpendicular to one of the chords, that diameter must have cut the chord in half. So that would mean that NS and US and TP and VP are all half of 48 inches, so they all must be 24 inches. Unlike our other problems, X is not one of the side lengths of a right triangle. Instead, it's a part of a radius. And I know the length of the whole radius is 30. So if I could figure out the length of OP, then I could subtract the radius in OP to figure out X. So I am going to have to use the Pythagorean theorem like we did on the other problems. So TO we knew was 30, and TP we knew was 24. So I can solve for the length of OP by using the Pythagorean theorem. And when you solve it out, you find out that OP must be 18 inches. And if the entire radius, QO, was 30, and part of that was 18, then the remainder must be 12. Our final example, we're asked to figure out the length of CE. We're told that AB is tangent to circle C, GA is a diameter of circle C, GA is perpendicular to chord DF, and GA is 360 meters, and AB is 240 meters. Well, if the length of the diameter is 360 meters, then the length of each radius would have to be half of that. So GC would have to be 180 meters, and AC would also have to be 180 meters. And since CAB is a right triangle, since AB is tangent at point A, it must have formed a right triangle, we can figure out the length of CB. Leg squared plus leg squared equals hypotenuse squared, or 180 squared plus 240 squared equals CB squared. So solve that out and we find out that CB must be 300 meters long. Now keep in mind that CF is a radius. So we would know that CF has to be 180 meters because radius CA was also 180 meters. Also remember that we were told in the given that this chord, DF, is perpendicular to diameter GA. So that means that this is a right triangle as well as this one. And they're actually similar right triangles. They both have a right angle, so that's one pair of congruent angles, and they share angle ACB. So according to angle-angle similarity, these two triangles have to be similar to each other, which means I can solve for their side lengths using proportions. For example, I could say that hypotenuse over hypotenuse, so little hypotenuse is CF, big hypotenuse is CB, is equal to leg over leg. So little leg is CE, big leg is CA. So fill in the numbers that we know and leave CE as the number that we don't know, cross multiply, and solve, and we find out that the length of CE is 108 meters. And that's all you need to know about calculating the lengths of diameters and tangents and chords in a circle. In our next lesson, we'll learn how to graph a circle in the coordinate plane.